Linear and versus Exponential Growth and Decay by Anish, Bondre, and Ryan Napier. So we're starting with linear growth. Brandon is saving up his money by doing chores. Currently, he has $15, and for each week, he earns $15. Create a table of values, a graph, and an explicit and recursive equation for the situation. So, for each week, Brandon gets $15 added to his total when he starts with $15. Explicit equation will be y equals 15x plus 15, and recursive equation will be start is 15, next equals now, plus 15.
Times 15.
Brandon wants to know how many weeks it will take him to buy a video game system that costs $345. Right there. Right, that equation right there. And so I subtracted 345 and 15 and got 330. After that, I divided 330 and 15 and I got 22 weeks. And since the equation is linear, the data forms a straight line.
Times 15. Next plus b. Oh, yeah.
So this is a linear decay
1.
right here. So there's a population of 300 tiger cubs that are in need of help. Each day, 5 of the tigers are rescued and taken to an animal rescue center. Write a table of values, recursive rule, explicit rule, and a graph for the number of tigers left to rescue. So this is the graph. There are 300 tigers at the start, and each day 5 are rescued. So that takes away 5 from the main amount. From the main amount of tigers still need to be rescued. So it goes from 3. So all I have to do is subtract 5 from the previous number to get to the next number. From the current number to get to the next number. So 300 minus 5 is 295. 295 minus 5 is 290. And on and on and on. And so this is the explicit equation. Because 5 tigers are taken away from the population of 300 each day, the slope is -5 because 5 are decreased. And there's a starting number of 300, so that's why that would be your y value. That's where we start.
Is in what year will each
to get from the number we have now to get to the next number, we have to subtract 5. So that's why our recursive rule is next equals now minus 5. So yeah, so now a question would be, how many days will it take for 170 tigers to still be in need of rescuing? Now, to do that, what I did was I plugged in 170 to y, and I tried to isolate x to get the variable. So I subtracted 300 from 170, and I got -130 equals -5x, and it is divided by -5. And x equaled 26. So it'll take 26 days for 170 tigers to still be in need of rescuing.
Oh yeah. So exponential growth. So Johnny went on a game show. When he started the game show, he started with $10. For every question he got right, his money from the previous round tripled. Create a table of values, a graph, and an explicit and recursive equation for the situation. So explicit equation is y equals 10 and open parentheses 3 close parentheses to the x power. Recursive equation is start is 10, next equals now times 3. So for every question Johnny gets right, he gets 3 times the amount of money he already has. For Johnny to get more than $100,000 in a game show, he'll need to answer 9 questions right, as it says the questions right there. So yeah, and so this is the graph, and since the equation is exponential, the line forms a curve. So yeah, right here. And
okay, so there's a planet of 10,000 bloodthirsty aliens. Each year, half of them are sent to further planets so they won't attack each other. Write a table of values, recursive rule, explicit rule, and a graph for the number of aliens still left on their own planet. So now, we start with the graph. There's a start of 10,000 aliens on the planet when no time passes by. each year, half of them are gone. So for me to get from the number I have now to the next number, I have to divide by 2 or multiply by 1/2. So when I multiplied by half, I got 5,000. When I multiplied that by half, I got 250, and then I kept on multiplying half until I kept on doing that until I got to the fifth year. So the explicit equation is y equals 10,000 times 1/2 to the x power. 10,000 is a starting value because that's the number of aliens that are on the planet at the start. 1/2 is the number is the number that you have to multiply to the number you have currently to get to the next number. So the recursive rule is next equals now times 1/2 because 1/2 is the rate. The start value again is 10,000 because that is the number you start with, and because this is the equation is exponential, so is the graph. And so the question was, how many aliens will be left on their own planet after 7 years? So I plug in 7 to x. I do 1/2 to the 7th power, which is 1 over 28. Then I multiply that to 10,000, which gets me 78.125. So it'll be about 78 aliens left.
The end. Like it says there.